Hello friends, welcome to another tutorial in Analog Electronics series. In this tutorial we'll talk about current mirror circuit. We'll talk about the concept of a current mirror circuit and then we'll see its implementation with BJTs. Now if this is something that interests you, then please keep watching. By the basic definition of a current mirror circuit, it is a circuit that keeps the output current to be equivalent to the input current. Now that might not hold true in all the cases because at some point in time we would want to define it as a circuit where one part of the current is equivalent to the other part of the current, and those 2 points are the observable points. Simply put, if we were to draw a block diagram of a current mirror circuit, we'll say that the current on one side of the circuit will be equivalent to the current on the other side of the circuit, and which is loosely called as the current at input should be equivalent to current at output, or the output current should be equal to or mirror image of the input current. Let's understand this concept with the help of BJTs. If we were to implement a current mirror circuit using BJTs, we'll need to use identical transistors. Over here I've used two transistors, Q1 and Q2, and the arrangement of these two transistors is such that the observable current here, I2, should be equivalent to the observable current here, which is IC1. So this might not necessarily be an output and this might not necessarily be an input, but the point of observation is on the extreme side of the circuit, and this point of observation is on this extreme side of the circuit. So I can say that if this being the input and this being the output, they are equal, so that will suffice the condition for being a current mirror circuit. Of course, these two transistors are identical and they are arranged in a specific way so as to satisfy this condition. The condition that needs to be satisfied is that I2 should be equivalent to IC1. So let's see how that happens in a current mirror circuit using two BJTs, and that two identical BJTs. Alright, let's look at the conditions for identical transistors. When we say Q1 and Q2 are identical, that implies that IB1 will be equivalent to IB2 and IC1 will be equivalent to IC2. They operate in the active region where beta 1 is equivalent to beta 2. So we can label them as A, B, C conditions, and both these transistors are operating in the active region. After that, we can see or prove that I2 comes out to be equivalent to IC1. And if that happens, we'll say this circuit is a current mirror circuit. So that is what we need to prove. They should be similar, identical, or mirror image of each other. To prove that, we take up this node. The starting point is to take up this node A. At this node A, I2 is entering, IC2 is leaving, I is leaving. So applying KCL at node A will give me I2 to be equivalent to IC2 plus I. And at node B, I is entering, IB1 is leaving, IB2 is leaving, so I can write I is equal to IB1 plus IB2. So we need to apply KCL at these two nodes A and B. Now from this discussion of identical transistors, we know that IB1 is equivalent to IB2, so I becomes equivalent to twice of IB1, or twice of IB2, whatever you may wish to write, because writing 2 IB1 will be more beneficial for us in solving. And finally, my I2 is IC1. My I2 is IC2 plus I, and I can write IC2 as IC1 from this discussion. So my I2 is IC1 plus I is twice of IB1. I can write I twice of IB1, and we know that IC is equivalent to beta times IB. So I can write IB to be equivalent to IC upon beta. So this IB is written in terms of IC as IC upon beta. So I take IC1 as common. I get 1 plus 2 upon beta in the brackets. And we know the value of beta is greater than 1, a lot greater than 1. So I can neglect this term. If I neglect this term, I'm left with 1 in the brackets, and 1 multiplied by IC1 is approximately equivalent to IC1. So my I2 gets equivalent to IC1. So this kind of an arrangement where two matched transistors are connected in such a way that my current I2 in this part of the circuit is mirror image of IC1 at this part of the circuit is known as current mirror circuit. And I hope you've understood the concept behind a current mirror circuit, and this tutorial was of help. If you liked the video, please give it a thumbs up. And if you have any doubts, ask them in the comments section below. Share the video amongst your friends. I'll see you around in the next video. Take care. Bye-bye.